Hello friends, welcome back. Today's video we are going to talk about introduction to Dockers and is this really a virtualization which is dead? We'll discuss in detail what is Docker, and virtualization is not dead, rather changing forms. So why Docker? And Docker is like, in order to understand Docker, I would say you would have to traditionally go back to the older way of doing the things. And if you see, before the virtualization was actually conceived, we would have a host, which is our hardware. We would have a host OS like Windows or Linux, and then we'll run applications on the top of that. That's what a traditional typical setup would go away. And then came more likely virtualization based computing, where a host plus hypervisor would be set up, which is like a virtualization. And then you would have multiple host operating systems. For example, you could set up a Windows VM, you could set up a, let's say, a Linux VM or whatnot. And then you could set up some apps, app one on host Windows, this one, and you could also set up some apps on host OS Linux, let's say the Linux based setup. This was more likely a virtualization that was introduced, and still virtualization is kind of a compute which is used. It is more likely a hardware virtualization, where even on a, let's say, a Mac based let's say hardware, you could use Parallels, or you could use VMware to run, let's say, Windows or whatnot. And then you could also use hypervisor or Microsoft's VM based solutions to run Linux on the Windows based VM. And then now, based upon the further categorization of the virtualization, we have a host plus hypervisor. And rather than we have multiple, let's say, host OS or like Windows or Linux, we normally typically would have a container engine, which is a part of the Docker. And then we could run app 1, we could run app 2, we could run app 3, which could run app 4. Now fundamentally this is what a Docker would look like, and that's why Dockerization has become very important. Now app 1, if let's say want to use a Linux, it could use Linux. App 2 wants to use Windows, it could use Windows. App 3 wants to use again a Linux, it could use that. So more likely, when the Dockers are the way still doing the virtualization, but then the virtualization is not based upon the hardware, rather it is based upon the software. So hypervisor will virtualize the hardware rather than the software, and containers, which is like run through the container engine within the Docker, it is definitely going to virtualize the software, not the hardware, the other way around. So I hope this kind of explain you guys what is traditional, then the virtualization came, and then now why we talk about Dockers and other things. So features of Docker, it's purely a PaaS platform, platform as a service model, uses OS level virtualization to deliver software in packages called as containers. Containers are very smaller unit of running actual pods. They are also called as pods, but then they are normally derived from the images which are hosted in some kind of what you call as the container registries or whatnot. So Docker uses both free and premium tiers. So if you want to use Docker, you could use a free tier of the Docker. And if we are dealing with a company or as a team, we could use more premium tiers for the Docker also. And then Docker engine is the core that does the magic at the backend, and will in the next slide I'll actually show you out how the whole architecture of the Docker works. But Docker engine is the core, and we could download Docker desktop, which is a free tool you could use on Windows, on Macs, for running Docker containers and creating your own custom images also. Okay, so now let's try understanding how the typical architecture of Docker works. So Docker normally works through certain command line arguments or command line features or SDK, which is a part of the Docker desktop. So we could use commands like docker pull, docker run, docker build. These are all the client commands. Like a client is gonna interact to a Docker daemon or a kind of a process that's running. So these are the commands which could be used. A client can give all those commands for different reasons, and the client is gonna interact with a Docker host. Now typically a Docker host contains the Docker daemon. It's a background process that runs around. A Docker daemon typically deals with two things. One is the containers and one is the images. Now fundamentally images is at a higher level. So let's say I want to run a Redis, I want to run a Postgres, I want to run ASP.NET. I can have these images which are stored within the Docker host. And now these are the images which are provided, let's say, by the software companies itself, or you could also create your own images. And containers, I would say, is the smaller part of the image that runs. So let's say I can run two different containers for Redis. I can run three different containers for Redis, or I can run one container for Postgres or one container of Redis. So fundamentally, container is the actual execution unit which is derived from the image, and image is a fundamental packaged kind of a software that is available to be utilized and to be run on the Docker software. Now, the client definitely interacts with the Docker host, and then the Docker host has a further interaction with the Docker registry. So Docker registry is more likely a kind of a public registry where the images are stored. You could have Docker registries which are private, which are public. Public images are more likely available to everyone. So for example, if Redis image is there, it is available to everyone. Anybody can download that Redis image, run those containers out of that, and could utilize that. But the private registries are more likely used by teams working for a typical software development or within a microservices project, which they don't want to expose it to a full-fledged public access. We could use the Docker's registry or even the cloud platforms. For example, Azure Container Registry is another kind of a repository where those images could be stored, or you could drive out those containers from those images. Similarly, AW has its own, and then even Google has its own. So fundamentally, it all depends upon how much you are invested in a particular, let's say, technology or a tech stack or a computing environment, and based upon that, you could actually use those. But fundamentally, a registry would remain a registry whether you use Azure, AWS, Docker, or GCP. So I hope, guys, this is a very basic introduction to the architecture of a Docker and why we use Dockers. And Docker is the next way by which we build microservices. If you are learning microservices, you firstly need to learn about what is a Docker, what are containers, because these are the very basic building blocks of microservices and microservices based development. Even if think about it, you are not actually developing a microservices. Let's say you want to run a software rather than hosting it on let's say running a full-fledged VM image, you could just run a Docker container image, play with that, work on that. You want to run it for a Postgres, you don't have to install the whole Postgres and anything. It's more like a temporary one. Install it, work it, test your software, and then deploy it. So that's why it is very much useful. Helps the developers in a lot of way to setting up the instances and running those workloads in just a couple of minutes and within few clicks. So thank you guys for going through this video. I'll be coming back with more videos, and till the time, stay tuned and have a good one. Thank you.